Alright, as a starter, what is the definition of current? What is Ohm's law and electrical resistance? We'll talk about resistivity today. We have talked about this before. We'll talk about resistance and resistivity, and hopefully we should be able to look at exam questions to calculate resistivity and the associated quantities with the formula. Alright, so if we look at the equation resistivity and resistance, so the equation R is equal to rho times L divided by A. Experimentally, the resistance of a metal can be described using that equation. So R is resistance, rho is resistivity, L is the length of the wire, and A is the cross-sectional area of the wire. And resistivity of the wire is just a constant for that wire, particular metal. So for example, the resistivity of copper will be different to the resistivity of iron, for example. So let's have a look at the proportionality. So from the equation, R is equal to rho times L divided by A, we can see from the equation that the resistance is proportional to the resistivity. So the higher the resistivity, the higher the resistance of the wire. Also, the resistance is proportional to the length. So the longer the length, the higher the resistance. So if you look at the bottom green box, here it says the electrons move through the wire, and that means that if you have a longer wire or a higher resistivity value wire, it would have a greater resistance. And then if you have a larger cross-sectional area, that means there is more space for the electrons to go through, and therefore the resistance is much lower. Okay, so if a wire is long, it is harder to push the electrons through that wire. And the units for resistivity is ohm meters. The greater the resistivity of the wire, the harder it is to push the electrons through it. So if the value for resistivity of the wire is higher, then the resistance will be greater. So let's just say you're looking for, if you compare copper and plastic, the resistivity of copper should be much lower than the resistivity of plastic. If the cross-sectional area is bigger, the easier it is to push the electrons through it. And resistivity is a useful tool in physics because it depends on the properties of the wire material. Alright, so let's have a look at this question. Values for resistivities can range from roughly 10 to the minus 8 ohm meters for copper wire. If you look at that, that's 10 to the minus 8, so that's very, very low. And for hard rubber, it is 10 to the 15. So remember, the lower the resistivity, the better metal conductor it is for electricity. And 10 to the 15 ohm meters for hard rubber. Alright, so the question is, suppose you want to connect your stereo to remote speakers. If each wire must be 20 meters long, what diameter copper wire should you use to make the resistance 0.10 ohms per wire? Okay, so let's have a look at the equation. R is equal to rho L divided by A, and I've put the quantities in the left hand side of the box. So from the equation, you know that L is 20 meters, you know that R is 0.1 ohms, you know that rho, which is resistivity, is 10 to the minus 8, and the question is asking for diameter, and you know that diameter is twice the radius. You also know that the equation for area is pi r squared. Alright, so you know that R is rho times L divided by A. Rearrange the formula to get A is equal to rho L divided by R. So this is just rearranging. You know that A, the area of a circle, is pi r squared. Put that in terms of D. So you know that D is 2R. Sorry, put it in terms of R. So D divided by 2 is R, and then put that into the equation A equals rho R, pi r squared. So now you know that pi brackets d over 2 squared, because d over 2 is r, so pi brackets d over 2 all squared is equal to rho L over r. Now you divide both sides by pi. You get d over 2 squared. Remember, d over 2 is just r, so d over 2 all squared is equal to rho L divided by pi r. And then square it both sides. Remember, the aim is to get d, so square it both sides. You get d over 2 equals brackets rho L divided by pi r all to the power of half. And you know that anything to the power of half is a square root. And then times both sides by 2. You get d is equal to 2, and all that square rooted rho L divided by pi r. That shouldn't be pi r squared there. Alright, so I've changed the r because before it was r squared, so now it's r. In this case, r is the resistance. Alright, so distance is equal to 2 square root of rho L over pi r. You know the values for rho, the values for L, and the values for r. Just put all those values in. You should get d is equal to 0.0021 meters or 2.1 millimeters. If the current to each speaker is 4 amps, what is the voltage drop across each wire? So you use Ohm's law, V equals IR. You know that the current is 4 amps and the resistance is 0.1 ohms. So you times them together and you should get 0.4 volts. Now, if the two resistors are in parallel, you use the equation on the left-hand side of this slide. So 1 over R total is equal to 1 over R1 plus 1 over R2. That's if it's parallel. If it's in series, R total or R equivalent is equal to the sum of the resistors. And we define conductivity as 1 over the resistivity. The symbol for resistivity is rho, and the symbol for conductivity is sigma. So sigma is equal to 1 over rho, or rho is equal to 1 over sigma. Alright, so let's have a look at this exam question. A cable used in high voltage power transmission consists of 6 aluminium wires surrounding a steel wire. A cross section is shown below. So you've got 6 circles of aluminium and 1 circle of steel. The resistance of a length of 1 kilometer of the steel wire is 3.3 ohms. The resistance of a length of 1 kilometer of one of the aluminium wires is 1.1 ohms. The steel wire has a diameter of 7.4 millimeters. Calculate the resistivity of steel. State an appropriate unit. So have a go at this question. Attempt this question first before I move on to the method, the working out. Now you are given the diameter, so work out the radius. So it should be half that, isn't it? So radius is half the diameter. And you remember you need to convert the millimeters into meters. Alright, so let's move on to the workout. So I've written down the quantities. So L is 1000 meters, the resistance is 3.3 ohms, and the radius is 3.7 millimeters. Remember, convert that into meters, you should get 0.0037 meters. So the first step, you work out the area, because you know that the equation is R is equal to rho L divided by A. So work out A, the area, using pi R squared. So you know R and you know pi. So the area should be 0.00043, and the resistance is 3.3, and the length is 1000. Put that into the equation, you should get 1.42 times 10 to the minus 7 ohm meters. Explain why only a small percentage of the total current in the cable passes through the steel wire. I've put part of the question inside here as well, just to remind you. So have a go at this question first before I move on to the mark scheme. Alright, so the mark scheme, the resistance of steel is 3.3 ohms and the resistance of aluminium is 1.1 ohms. So you can see that the resistance of steel is higher than the resistance of aluminium. So therefore the current is higher in the aluminium. Alright, so let's have a look at the mark scheme. So the current in the steel wire is less than the current in an aluminium wire as it has a higher resistivity. So therefore aluminium is a better conductor. That's for the first mark. The 6 aluminium wires are in parallel, or total cross-sectional area of the aluminium is 6 times greater than the steel wire. And each aluminium wire carries 3 times as much current as the steel wire. Alright, next question. The potential difference across a length of 1 kilometer of this cable is 75 volts. Calculate the total power loss for a 1 kilometer length of cable. So I've given you the equations. The power is equal to current times voltage, and Ohm's law, voltage is equal to current times resistance. Now we've only got the resistances in the question, and we've got the voltage in the question. We don't have current. So I suggest you eliminate current and find the equation for power in terms of voltage and resistance. Right, so have a go at this question first before I move on. Alright, so before I have a look at the mark scheme, this is the diagram of what it looks like. So here you've got 6 aluminiums in parallel and 1 steel that's in the center. So the diagram should look like this as a circuit. So you've got 1.1 ohms in parallel, and you've got the 3.3 ohms in parallel as well, but there's only one of them. So to work out the total resistance, you do 1 over 1.1 plus 1 over 1.1 and so on, and 1 plus 1.3 is equal to 1 over R. And you should get the total resistance of those 7 wires in total as 0.174. And the equation for power in terms of V and R, you should get P is equal to V squared over R. You know V is 75, you know R is 0.174. Put that into the equation, you should get, so here you should get 33.3 kilowatts. So this is the mark scheme. So have a look at the mark scheme, pause the mark scheme and have a look. Alright. This is another question. The critical temperature of tin is minus 269 Celsius. The resistivity of tin increases as its temperature rises from minus 269 Celsius. Define resistivity. This is 2 marks. So have a go at this question first. Alright, so in the mark scheme, resistivity is defined as rho is equal to RA divided by L. So I have given you the equation here, and the equation was R is equal to rho L over A. If we go back to here, so here you just have to rearrange the equation. Just rearrange the equation. So rearranging the equation, rho is equal to RA divided by L, where R is the resistance of the metal of length L and cross-sectional area A. Right, and next part of the question. A sample of tin in the form of a cylinder of diameter 1 millimeter and length 4.8 meters has a resistance of 0.70 ohms. Use these data to calculate a value for the resistivity of tin. So I've given you the equations for the area, and I've rearranged it for you because R is equal to rho L divided by A, rearranging to get rho is equal to A times R over L. So have a go at this question. You should be able to work it out now. Let me just state what the question is below, question 6. At room temperature, a metal has a resistivity of 4.5 times 10 to the minus 7 ohm meters. A wire made from this metal has a radius of 0.70 millimeters. Calculate the resistance of a 2.5 meter length of a wire at room temperature. Alright, so the mark scheme is shown below. So for the first part of the question, you should get 1.15 times 10 to the minus 7 ohm meters. And for question 6, you should get 0.73 ohms. Alright, the next part. Calculate the power dissipated in this length of wire when it carries a current of 20 milliamps. Assume the resistance of the wire is constant. So again, I've put the previous part of the question. The previous answer was 0.3 ohms. The equations are P equals IV and V equals IR. How do you work it out? Alright, so again, you use P equals IV and V equals IR, but you need to combine those two equations in terms of I and R, because you worked out R previously was 0.73 and I is given in the question, which is 20 milliamps. and you should get 2.92 times 10 to the minus 4 watts. Alright, so have a go at these questions yourself. What is the resistance of 180 meters of silver wire having a cross-section of 0.30 millimeters squared? The resistivity of silver is 1.6 times 10 to the minus 8 ohm meters. Question 2. The resistivity of aluminium is 2.8 times 10 to the minus 8 ohm meters. How long is the piece of aluminium wire with a 1 millimeter diameter needed to give 4 ohms? Now for question 1, you need to convert the millimeter squared into meter squared. So you need to convert that. What is the conversion? Find it out yourself. See if you can work out. Okay, well, 1 millimeter is 10 to the minus 3 meters. So 1 millimeter squared is 10 to the minus 3 meters all squared. So therefore, 1 millimeter squared is equal to 10 to the minus 6 meters squared. Alright, so these are your answers. You should get 9.6 ohms as the answer to the first one, and 112.2 meters for question 2. Another question. If 3.0 times 10 to the 15 electrons flow through a section of a wire of diameter 2 millimeters in 4 seconds, what is the electric current in the wire? Now this is the previous part. You just need to know the definition of current. Current is the rate of flow of charge. You need to work out what charge is. Now the charge of one electron is 1.6 times 10 to the minus 19 coulombs. Alright, so here's the answer. So you need to work, so if you know that the charge of one electron is 1.6 times 10 to the minus 19 coulombs, and you've got 3 times 10 to the 15 electrons, you times both of them together, that will give you the total charge, and then you divide by the time taken, which is 4 seconds. You should get 1.2 times 10 to the minus 4 amps, or 0.12 milliamps. Next question. Calculate the current in a piece of 10 meter long 22 gauge, and you're given the radius as 0.321 millimeters. Remember, convert that into meters. If it's connected to a source of 12 volts, you're given that the resistivity is 100 times 10 to the minus 8 ohm meters. Have a go at this question. Alright, so here's the solution. So the quantities are L is equal to 10 meters. You know that the radius is 0.32 millimeters. Remember, convert that into meters, which is 0.321 times 10 to the minus 3 meters. You know that rho is 100 times 10 to the minus 8. And V is equal to 12 volts. First, we need to find out what I. So what is I? That's the question. So find I, you need to use Ohm's law. V equals IR. But how do you work out R? Well, you know that R is rho L divided by A, and you know that A is pi R squared. So you put all those values in, you should get R is equal to 30.9 ohms. And then using Ohm's law, rearrange Ohm's law, V equals IR, to work out I is equal to V over R. You've just worked out R, and you're given V in the question. You do V divided by R, you should get 0.388 amps. For these questions, you've already got the answers to these questions already. So the answers to the first box is D, the answer to the second box is B, the answer to the third box is D, and the answer to the fourth box is E. Now your task is to explain why the answers are given in the box.